Hey, this is Professor Cummings. I'm here to give you a few examples of linear differential equations. So up to now, what we've done, we've given you a little bit of the concepts, so a little bit of the intuition of a linear differential equation and how what you would apply this to. So mixing problems, electrical circuits, capacitor resistance type setups. So then we went through an example or a setup of the integrating factor, and now I want to give you an example, putting it together. So from the last time video up there, or last video that got published, I gave you 4 steps to solving a linear differential equation, first order linear differential equation. I'll put a link in the description box or a link down below so you can go see that video if you want to check it out. Okay, so the first thing is, once you recognize the standard form, and once you look at the different and recognize it is actually in a standard form, or it is a standard form, it has all the components of a standard form. Let me put this into the laser setting. So you got a standard form of dy dx plus p of x times y is equal to f of x. So you've got a first order, so it means the exponent of the dependent variable and its derivative is 1, and it's the first order, so it means it's the first derivative. So you've got dy dx plus p of x, which is just a function of x, times y is equal to f of x. You got this into its standard form. Once you've done that and recognize that it's a first order linear differential equation, now you can start the 4 steps of solving this first order linear differential equation. And these 4 steps are only to get you a general solution. A particular solution, you're actually going to need an initial value. So for the 4 steps of solving a first order linear differential equation, and first, once you got it in standard form, you can recognize what p of x is, and you can find the integrating factor. Like I said, I have a video on what the integrating factor is and how to derive it. You don't need to know that just to solve the problem, but it does give you some insights as to why this whole thing works. It puts it into the form of the product rule, so it makes it easier to integrate. So you find the integrating factor, then you integrate, actually go through the integrating factor and creating the product rule. So you multiply both sides of the equation by that integrating factor. So you multiply through, so you have the integrating factor times the derivative of y, so dy dx, plus p of x times the integrating factor times y. And so this is just the variable, and this is its derivative, and the variable of y and its derivative over here. So you can see that it is indeed the product rule, and multiply that through, and you have the f of x times the integrating factor. Now once you have that, you can put it in the form that the product rule takes, which is just this is a derivative. So you got the integrating factor times y, the 2 variables, is equal to f of x times u. Okay, so now it's easier to integrate. You've got this, this derivative is equal to a function times the integrating factor. So your third step is to actually perform the integration. So integrate both sides of the equation. So that's pretty self-explanatory. Take the antiderivative of the left and the right side. So the antiderivative of a derivative is just going to be the argument, and the antiderivative of the right side of the equation, that's going to be basically a part of the general solution. And then solve it explicitly for y, just another way of saying divide by the integrating factor. And so you have y is equal to 1 over the integrating factor times the integral of f, or antiderivative of u of x times f of x with respect to d of x. So those are the 4 steps to solving a first order linear differential equation. Again, that was in the last video, but I think it's important to see this before we do the actual examples, because those are the 4 steps you're going to see come into play each time. So let's look at an example, and we've got this equation here. 3 is equal to dy dx plus 3 times y is equal to 4. Now right off the bat, you can see this is not in standard form. We've got a coefficient in front of the derivative. So if we divide through by 3, divided by this coefficient, it'll be in standard form. Okay, so we got our original equation, 3 times dy dx plus 3y is equal to 4. You'll put it into standard form by dividing all through by 3. So now we have it in standard form, dy dx plus y is equal to 4/3. So we got it in standard form. So next step, now our next we get it into our 4 steps. So the first step, find that integrating factor. And that's u of x, which is equal to e raised to the antiderivative of px dx. And you look at this equation, p of x is actually just 1. So it's an implied 1. So p of x is 1. So the integrating factor is just e raised to the antiderivative of 1 d of x. And that comes out to just e of x. So now we can go through our next step, which is just multiply through by our integrating factor. So it's ex times y prime plus, or that could have been dy dx, just a different notation, plus e of x times y, or e raised to the x times y, is equal to 4/3 e raised to the x. Okay, so now that's in the product rule, so we can look at it slightly different, which is just the two variables, which is e to the x times y, which is a derivative of the product rule. So it's just in this derivative form, and the antiderivative of the other side, 4/3 e to the x dx. Okay, so now this becomes easier. On this side, the antiderivative is just the argument, ex is equal to the antiderivative of 4/3 ex dx. Now when we integrate this, 4/3 is just a constant, comes outside the integral, and ex, the antiderivative of e to the x, is just e to the x. And then we have our constant of integration. Like I said, we're still looking at this as a general solution. So now the last step, we have to solve this explicitly in terms of y, which is just dividing by e raised to the x. Oops. So now you have y is equal to 4/3 times e to the x times e raised to the negative x, or divided by e to the x would have been the same thing, plus c times e raised to the negative x. So dividing through by that, and then we can simplify it, and it's just y is equal to 4/3 plus c times e raised to the negative x. And this is just the formula that I showed you in the earlier part of the presentation. So that's one example. Now let's do another example. So in this one we have x squared plus dy dx plus x times y is equal to 1. So again, this is a first order linear differential equation, but it's not in standard form. So we're going to have to go ahead and go to that p of x, or dy dx plus p of x times y is equal to f of x. And the way we have to do it is get rid of this coefficient again. So there's the equation, divide through by x squared, and we end up with y over x is equal to 1 over x squared, or that could be x to the negative 2. So we do our integrating factor. So we know p of x, in this case p of x is just 1 over x. And to solve the integrating factor, it's just e raised to the p of x d of x, our antiderivative of p of x d of x. And 1 over x, antiderivative is just natural log of x. So e raised to the natural log of x, the e cancels the natural log, and you just have x. So our integrating factor is x. Now we multiply through by our integrating factor, in the standard form equation, and we have x times dy dx, plus x times y over x is equal to x over x squared. Now this one can obviously be simplified pretty dramatically, but you got to remember, we're just trying to take the antiderivative of both sides, and since this is in the product rule, So this is a product rule. We can go through with this and make it a little easier on ourselves. So the antiderivative of the argument x times y derivative is equal to the antiderivative of 1 over x, which this would simplify to as 1 over x dx. And the antiderivative of this equation is just the argument x times y. And the antiderivative of 1 over x is just natural log of x plus c. So now we have this equation here. X times y is equal to the natural log of x plus c. And now we go to our last step, which is divide through by the integrating factor. And that is y is equal to 1 over x times the natural log of x plus c over x. So again, we can see we went through the 4 steps. We put in the standard form, and we got the integrating factor, which is what I'm calling the first step. Multiply through by the integrating factor, divide, multiply through by the integrating factor, and then take the antiderivative, which is fairly easy because you've got you're using the product rule, so you're just looking at that argument. Then we go through and once we've got the antiderivative of both sides, we divide through by the integrating factor and solve it explicitly in terms of y. Let's just do this one last example. Again, none of these are in standard form, and there's always this coefficient in front of dy dx. So we have x times dy dx minus y is equal to x squared times sine of x. So this one's a little more complicated, gives us a few more things to look at. So we got our initial equation. Like I said, this isn't in standard form yet. So we've got this coefficient, we've got to divide through and simplify this, put it into standard form. Okay, so we have dy dx minus y over x equals x times the sine of x. There's one more thing I want you to notice in this particular one that wasn't the case in the last one. This is actually a minus sign here. This is going to become a part of p of x, which will then in turn become part of our integrating factor. So it's important to note that in standard form, the integrating factor is positive. So that negative sign is an implied -1. You could think of it as an implied -1. That becomes part of p of x. So our integrating factor is a negative x to the -1, or you could think of it as a -1 over x. The antiderivative, or e raised to the antiderivative of negative x raised to the -1 is equal to the e raised to the negative natural log of x. Now, part of the rule of exponents, the way we can get rid of this with base e and logarithms, is the coefficient on this natural log of x can become the exponent of the argument. All right, so once you've done that, once you've made this the exponent, so raise this to the natural log, or negative x, or -1, the e and the natural log actually cancel. So you end up with an e raised to the -1. So that's what went on in this one. So this is e raised to the -1, or 1 over x, if that one is easier for you to look at. That's the integrating factor. So the integrator is 1 over x, multiply through by that integrating factor, from the standard form. All right. So now we want to take the antiderivative, which is just the two variables, or the argument, which is just 1 over x. So 1 over x, and then this is y. So that's the derivative. Remember the product rule. And the antiderivative of this side, the x's cancel, so you're just left with the sine of x. So the antiderivative of the sine of x. Again, the antiderivative of a derivative is just the argument, so y over x. And the antiderivative of sine of x is the negative cosine of x plus c. One last step, divide through, or in this case multiply through by the integrating factor, solve it explicitly in terms of y. So you end up with a negative x times the cosine of x plus c x times c. So I hope this was helpful. This is just a few examples of solving first order linear differential equations. These were all general solutions. I didn't have give